So I'll try to share my screen. I hope you see it. So yeah. So okay, I see some questions here. So or doubts. So even though it's WebRTC, is most probably not peer-to-peer, as like my single computer wouldn't probably be able to stream to you all. So we have a server in the middle, and that's where Elixir WebRTC runs actually. But this presentation will be about Boombox. I heard about like people trying it, and that's very cool. And I also heard some doubts and problems. So in this stream, I will try to address some questions. And if you have more questions, then please ask them on the chat. And I'm going to start with like some basics about the software mention, open source projects, and Boombox, and like some details like by very like basic things about Boombox and how it works and what it's for. And then we'll try to implement something cool with Boombox. So let's get to it. So firstly, we have some media projects in software mention, and they are often referred to as membrane, but they are not necessarily membrane. To like make it perfectly clear, I'd just like to talk a little bit about all of those projects. We use probably VP8. First, Elixir WebRTC. So it's the software that this stream runs on. So it's a pure Elixir or WebRTC implementation, as we already said. Generally, it used to be the WebRTC implementation used to be a part of Membrane, but we separated that. We even rewrote that. That is the Michał's team, and that's because like Membrane is a kind of abstraction over many things. It allows you to interact with many protocols, many codecs, but it's not necessarily good that you have to use that abstraction in order to use WebRTC in Elixir. And also like this disentangling WebRTC from Membrane made it possible to like create a very standard compliant API that you can find in other WebRTC implementations in other languages. And also like WebRTC is quite a complex thing, and it's quite a bit effort. So it was also great to like separate the teams and separate that work. So now we have like WebRTC, Elixir WebRTC that is used by a membrane, but Elixir WebRTC itself doesn't depend on membrane. Another project is Live Compositor, and this one is written in Rust actually, and it's about like compositing different videos. So if you have, for example, two videos and would like to stitch them like together, or even apply some shaders on them, animations, add like subtitles, bake them in. If you want just like baked in a software mention logo on this stream, then we could use Live Compositor. However, it's like best suited for a bit more complex use cases than that, I think. It's a standalone server that you can control with HTTP API and even with React lately. However, it also has a bindings for Membrane, so you can like use that within your Membrane pipeline, and the server will be automatically spawned and managed by the Membrane components. And finally, we have the membrane, so the framework, so the abstraction over many things that uses pipelines to connect them together. So we have plugins for Live Compositor, we have plugins for Elixir WebRTC, and various other plugins. Actually, we also have like many other implementations, like codec or protocol implementations that are within the framework. and I think it could be useful to like separate them as well, so that people can use them independently without like relying on the framework. So for example, HLS and MP4 and H.264 and H.265 utilities are very like we have quite an advanced implementations of them. So I think there have been some third-party efforts to separate them, so to have like a clear boundary between the particular codecs and the membrane abstraction. So if you would like to get involved into that, perhaps then that would be a very welcome contribution. And we have Boombox, so the one that we are going to talk today. So Boombox is like kind of a quite lightweight layer on top of membrane that allows to do some things that you can do with membrane, but simpler. So to go a little bit into detail, like the approach of Boombox is that it's a library. So you call the functions instead of membrane being a framework when you provide the implementations, and the framework calls these implementations. Also, membrane consists of many plugins, while Boombox is a single package. You either use Boombox or not. With membrane, you have this option to customize. However, you need to know which plugins to use and how to use them, and which plugins you need. So that's the complexity. With membrane, you explicitly specify what should happen with how the media should be processed. But with the Boombox, you can treat it a little bit like as a black box. So you basically tell it what it should be done instead of how you do with membrane when you focus on how it should be done. So these are basically different trade-offs, and while we can make membrane a little bit more automated and Boombox a little bit more extensible, then we still will be leaning towards these different trade-offs in these two projects. So basically what actually we can do with Boombox. So there are basically two main usage scenarios, and the first one is media delivery and the other one is a media relay. So media delivery is basically about taking media from somewhere and putting it into your Elixir code so that you can do something with them, or taking the media from your Elixir code and sending it somewhere. Like a simple example can be that you can take the video stream from the browser, send it to the backend, receive it with Boombox, and then, for example, do some image recognition or image classification on that. So to do the media delivery, what happens inside Boombox is that it receives media and then it demugs the media. So the receiving part is just taking the media from the socket, but it also involves some connection establishment, which differs from protocol to protocol. And demuxing is basically unpacking the media. So for example, if you can have audio and video, then you need to somehow determine what part of the stream is audio, what part of the stream is video, and then you also need to take into account a different metadata about these things. So this can be a bit complex process. However, the cool part is that it's quite lightweight and it works quite fast. And the next step is the decoding part. So that involves the actual compression. So especially for video is the heavy part. So you have to take this compressed thing, like for example VP8 or H.264 or AV1, which we don't yet support, and you then you get the actual raw frames with pixels that you can operate on. And finally, you are able to process the media. And on the the other way is basically the reverse flow. So you generate media or take it from somewhere, then you pack it into a container, into a protocol, and actually, I have mistaken these two steps. First, you encode, then you pack, of course, and then you send the media somewhere. So when we relay the media, that basically means we receive the media from some place and then we send it to another place. And why should we do that? Well, there are various reasons. Like the most common media relaying scenario is like this one, which we have in currently in this stream. So I am sending the media to the server. The server receives the media and broadcasts this media to all of you. So I couldn't broadcast this media from my laptop because I don't have such a powerful link. I don't have such a powerful compute possibilities, so that I need a relaying server for that. Another use case is, for example, when you have a camera that looks at your backyard, then this camera probably uses RTSP under the hood, and this cannot be streamed directly to a browser or to your smartphone when you want to see it, or at least it's not trivial to do that. To the browser, indeed impossible. So you have to have a relay that will convert the protocol to the adequate one. So media relaying, we could do that with receiving the media and sending the media. So combining the two scenarios that we saw before for media delivery. However, as I mentioned, the decoding and encoding process can be quite compute intensive and resource hungry. So we can try to get rid of that. And we only have the receiving, the maxing and sending. So that's way faster. However, that involves a lot of corner cases and quirks. Sometimes we cannot do that because some protocol doesn't support particular codec. Sometimes we can do that only for video, but not for audio. Sometimes it requires changing somehow the structure of how the encoded stuff looks like. So not necessarily decoding, but a little bit tweaking the encoded stuff. And that's what Boombox aims to do for you, so that you don't need to care about it. And Boombox figures out whether it has to decode, encode, and how to change the media for these protocols input and output to be compatible. So what are these protocols in Boombox actually? So let's take a brief look at that. So the first one is WebRTC, that is used via membrane via Elixir WebRTC. So that gives us very low latency, as you can see currently. However, it also involves some complexity. And with the very low latency comes sometimes the reduction of the quality. So that if we had 5 seconds latency, then possibly if a packet is lost on the way between the server and your machine, then we are able to retransmit that packet and repair the video. And I can try this slower. However, we get this very low latency with WebRTC anyways. And if we a bit more of latency, that we can use RTMP, which is very, very old protocol. However, it's also very simple and working in practice. That's why it's still widely used. So if we had a standard implementation of the Twitch clone or the actual Twitch, it just uses RTMP under the hood to get the media from the OBS to the server. So RTMP is still considered real-time. However, it introduces some overhead. Another thing is RTSP, which you can usually see at the in the CCTV cameras. However, this can be perceived as an older and simpler version of what WebRTC is. So you have some media negotiation. We have low latency, but we don't have some of the features that WebRTC provides. However, it's also like a simpler protocol. More implementations exist. Many CCTV cameras support it. And yes, indeed, Boombox supports packaging into the HLS streams. So like the standard Twitch scenario, like for the egress part uses HLS indeed, which also provides a little bit more of latency. However, what the great thing is that we can use regular CDNs that use HTTP to broadcast the stream to masses. As for WebRTC, if we didn't fit into a single machine, like in this stream, we would have to have many of these machines running by ourselves probably, or using some custom WebRTC relays, which are more expensive and less available than the CDNs. So these are the trade-offs. Yes, there are a lot of acronyms. I can maybe unveil them a little bit. So WebRTC starts for web real-time communications. RTMP starts for real-time messaging protocol, probably. And RTSP stands for real-time streaming protocol, I guess. And HLS stands for or maybe signaling protocol. And HLS stands for HTTP live streaming. Finally we have MP4. So it's not really a protocol, but a container. However, from the packaging perspective, it can be perceived in a similar way. So MP4 we all know and like. However, it's quite a complex thing. In Boombox, it allows you to dump the stream to a file or read it for a file. That's the most commonly used container for that. So that's why we also have that in Membrane and Boombox. So I'm not really sure if that makes you really more comfortable with these protocols, but it was a really quick overview. So if you're not into them, then definitely you can read more about them. There are many resources, including our Membrane Mondays tweets on Twitter or X, when we try to introduce to you some media terms and acronyms and protocols, so that they're a little bit more accessible. So if you're interested, then follow Elixir Membrane on X. Yes. So that brings us to something that we will try to implement today. Basically, the scenario will be about the media delivery. So we are going to deliver the stream via WebRTC to a server, then pass it to OpenAI API, and then deliver the response back to the client. And with that, we can implement a simple chat with an AI bot, basically. And that has just become a little bit simpler than it used to be, because of OpenAI introducing multimodal live streaming API. And basically how that works is that it takes the audio and converts it to the tokens, and then these tokens are directly interpreted by the ChatGPT. And then ChatGPT also produces tokens, and these tokens are converted directly into audio. So we don't have to use any speech-to-text or text-to-speech mechanism in between, and that saves us a ton of complexity. And actually, I learned that at the RTC On that we had in September. That was a wonderful talk by Rob Pickering. I can post it on the chat. So yeah, so basically an important thing about like talking to AI agents is that it for now it usually looks like you need to like apply several techniques in between. The first is voice activity detection, so that like the software like knows when you speak and when you're actually finished speaking, when you start speaking, and then speech to text, so that you can convert this audio to the text, and then you put that into like LLM, so ChatGPT for example, then you convert that to speech again with some text to speech model, and then you send that to the user. And each of these steps adds, for example, latency, apart from complexity, so it takes quite a lot of time, and to like get rid of that latency, you need to get rid of that latency, you need to apply some weird techniques, which are in more detail explained in that talk. And there are also other different problems that come with implementation of such a software. And these are listed here basically, so time prediction, latency interruptions, and controlling the conversation. So I encourage you to have a look at this talk to get into it more. But for now, let's see how we can get rid of it all and just use the API. Okay, so here's my presentation. And here I have started implementing it already. So I implemented it basically today. So it may or may not work. Basically, what we have here is OpenAI WebSocket module that uses WebSockets to interfere with the ChatGPT APIs, OpenAI APIs. We can start it, we can send audio to it, and then it will basically send back the audio to us. The first thing we can notice is that it uses WebSockets, and what's more, it even uses base 64 encoded audio. So that's like not really a usual way of dealing with audio. However, somehow like OpenAI decided to go that way. So the problem with this approach is that it uses a ton of bandwidth, and it like especially that is like not compressed audio. That's why that's one of the reasons why we shouldn't like let user directly connect to this API. It's better to forward it through your server. Another thing is that you basically don't really want to expose your AP key for the OpenAI chat to the public. And finally, you may use something else than OpenAI, a self-hosted thing. There are also like implementations of multimodal LLMs that are open source to my knowledge. However, I don't recall names currently. Yeah, basically that's the reason why we actually should do what we are going to do currently. Again, this is a simple wrapper over OpenAI API. and we're installing Boombox and WebSockets. I take Boombox from my local hub because I did some tweaks that are only here at my computer for now. So not all of this is going to work with the version of Boombox that is accessible anywhere. However, I'm going to push that today or tomorrow, at least to a branch, so that you can all use that. But I will explain what and how later. So the first thing we're going to do is to get the stream from the browser and pass it to this OpenAI API. For that, we're going to do boombox.run. Actually, I can zoom in a little bit. Okay. Cool. And the input is going to be WebRTC. And we're going to use WebSocket for the signaling. So one thing about WebRTC is that it doesn't standardize the signaling part. So it standardizes how the media are sent, but it doesn't standardize how to establish the connection actually. So there are many ways to do that. One of these ways is to use WebSocket for this. So that's what we do here. However, the media don't go over WebSocket; they go over the WebRTC connection. We're going to listen at this port because I created a simple frontend that will connect to that particular port, and the output is going to be a stream, and this will be actually the Elixir stream that you can access with enum and stream modules, and we're going to not receive any video. And get the decoded audio. Cool. Now we need to specify what kind of audio we need, and this is going to be what actually the OpenAI expects. And there are several features of the decoded audio that we have. The first one is audio format. And this means basically that each audio sample is a 16-bit integer, low endian, and audio channels. In this case, we're going to need a single channel, and audio sample rate. So how many samples are we having per second? And the OpenAI requires like to 24K. Cool. Now we can use a regular enum function to get the packets that we are going to receive. So for each of these packets, we are going to basically send the packets to the WebSockets adapter with I have this here, send audio function. And the actual audio resides in the packet's payload field. So we don't have the WebSocket yet, so let's start it. Cool. And what should happen now is that when we send this audio, this WebSockets adapter will do two things. After actually receiving the response from the API, it's going to either get the actual audio response, and this will be sent to some target. So we'll get into that later. And it will also send the transcription of the audio that it produced, and this will be logged. So for now, we are going to get some transcriptions. So let's try it. Cool. So now it awaits me to connect from my browser to it. So let's try to do that. Connected, cool. It already thinks that I'm asking it something. So maybe tell me what's the capital of Poland. Yes, so indeed we got an answer and a transcription. It took a while because it actually needed to produce the whole answer, and then it sends us the transcription. However, when we get the audio response, we actually get it quite instantly. So we are going to try that now. So what we are going to do is to run another instance of Boombox that will receive the responses and send them via WebRTC to a browser. Actually, we're going to start with receiving the responses from the API. So stream repeatedly. So this function, this stream repeatedly gets a lambda and calls it like one again and again as something consumes the stream, and this something is going to be Boombox actually that will be consuming the stream. So we're going to receive some data here. So audio. And once we have that, then we can pack it into a Boombox packet. So this is just a struct that needs a payload. So the data, a kind, which is audio in this case. And it also needs a format. So basically, as here, we provided the format that we want. In the Boombox packet that we return, we need to specify the format that we actually return. So it's going to be the same as we had it here. So yes, that's it. And then I'm going to pipe that into a Boombox call. And here we specify the input, which will be the stream again, a binary audio, and we are not going to send the video. And the output will be similar to what we have here, but on a different port. So as far as I remember, it was that one. Let's hope I got it right. Yes, and another thing that we are going to do is to wrap this within a task, because like we need them these two streams to run concurrently. And yeah, actually another thing is that this is going to fail because of like bit of annoying limitation of EXS scripts that like Elixir tries to parse the entire script first, and it doesn't know the Boombox packet struct because it's not because it's in a dependency, and the installing of the dependencies happens in mix install later. So that's why we need to wrap that into a module and a function, and then call that function. So I usually call that run. And let's put that inside. Cool. So now we should have it, and let's see if that works. Oh, actually, it's within the audio prefix. Maybe we should have made it compatible, like to avoid confusion. And now what's wrong? Oh, okay. Actually, it was good. It should just be within another field that's called format. Let's try it now. Okay, at least it compiled, so half of the success. And we're connected. So hello AI. Oh, okay. So first thing, I have my headphones on, so you won't hear anything, but I don't hear anything either, so I probably messed up something. So let's first disable my headphones and then figure it out. So let me look at what I implemented earlier. Everything should be okay. Maybe that should be true. Let me refresh it. For some reason, it keeps trying to speak Spanish. However, oh, now it speaks Spanish a lot. That's weird. So yeah, I have no idea what happens right now. So let's try to look at it again. So yeah, we run the WebSocket again. Oh, maybe I messed up the message that I'm supposed to receive from the WebSockets wrapper, because it sends a response, not audio. So it may be that. Let's change that. Hey, please don't speak Spanish or French or whatever. Just English, please. Oh, it doesn't hear me because I didn't connect. Okay, again. Hey, please don't speak French.
Got it. I'll stick to English. How can I help you today?
So can you hear that? Because I'm not sure if that's not noise cancelled.
I can't hear sounds or noises, so I wouldn't be able to tell. Sure thing. Just let me know what you need.
So please tell me what's the capital of Poland?
The capital of Poland is Warsaw. Anything else you'd like to know?
Yeah. What can I eat in Warsaw?
Oh, Warsaw has some delicious options. You can try traditional Polish dishes like pierogi, which are dumplings filled with meat, potatoes, or cheese. Bigos, a hearty hunter stew with sauerkraut and meat, is also popular. And don't forget to try some Polish sausage or kielbasa.
Damn, it's pretty right.
Yes, beetroot soup, another classic. It's a vibrant red soup,
please.
often served with a dollop of sour cream. Perfect.
So as you could see, it works. The one thing that doesn't work is actually interrupting it. So when I try to speak, it doesn't stop. However, it seems that the API handles that as well. However, the problem is that it sends the response a little bit faster than real time. So when we feed that into Boombox, it will happily accept it and buffer it and then keep it there. So like we would need a way to just flash the stream, like the stream that is not to be like forwarded. For example, if the chat produces a 5 minutes response and we need to break it, there is a chance that all these 5 minutes response will be buffered within Boombox. So we can either like try to add an option to Boombox to like make this window a little bit smaller, so we don't consume the stream beyond the level we need actually. And then there is the of course the problem of figuring out how much should be consumed, because we need to have enough data to avoid like any like scattering and other like effects that are not really desired. And another thing that can be done already is probably like not sending the data to Boombox beyond some amount, so that we can drop the data, not send it to Boombox, and just send like the further response that is actually relevant. I'm not sure if I will be able to make that today. So possibly we're going to end up with what we have. And if you have any questions, I'm happy to answer them. So please ask on the chat. So I'm going to get back to the presentation so that you can see the domain we just bought because it was cheap and cool. So that now when you go to boombox.run, it will redirect you to our GitHub page. Will the code be available somewhere? Sure, I can post it on Twitter, so you have a reason to follow me. Here is my Twitter handle, or X, and here is the Elixir membrane Twitter handle, which we have, where we post news about membrane itself. Don't hesitate to follow. I've been doing live coding several times already on stage, and I'm waiting for the time it breaks totally and miserably, so that I won't do that anymore. But I'm lucky so far, so I'm doing that. We had some questions. So indeed, there is a great, surely great interview with Jose at Twitch. So if you'd like to watch that, then definitely I'm going to finish in a moment. I'm just going to answer some questions that were here. So at least that I am going to comprehend. So the variable audio that gets base64 encoded is that binary representation of the sound. Is indeed a binary representation of the sound, and then that we can like forward to Boombox. We cannot just forward text to Boombox because we don't have like the text to speech there, and maybe you will have, and maybe not because it won't be needed because of features in LLMs like this one. Cool. Okay, I don't see any more questions in the chat. So I'm going to thank you for today, and specs of the single server. I think we thought that already. Like Michał thought about that at the very beginning. So there is a single machine that has 32 cores and 62 threads. And for like 400 people that we had yesterday, it was occupied in less than 30%. However, like the CPU consumption of Erlang virtual machine is always a little bit of a misery because of like kind of busy waiting on some threads and like trying to occupy more resources than it necessarily needs at the point. So we are yet to see how many people we can like have on a single machine. And yes, did I miss anything else? Oh, did you say there was a limiter? I'm not sure what kind of limiter you mean. Audio limiter. I don't think I said that. I still am not sure. You mean that the like cutting reducing the volume or clip preventing or exactly. So we're not doing that anything like that. I think that's on the side of the browser to do that because we get the stream from the browser. So basically that's on its side. Cool. So I think that tomorrow we are going to have a stream by Chris. Let's check that. Yes, indeed. So the Chris will be probably showing something similar, how to build something similar that we have here, but using live view and live components. Actually, this page also uses live view, but as far as I know, in that part, there will be more live view and WebRTC components within live view. Yes, maybe he will publish. So I'm really looking forward to that, and I wish you a happy and insightful rest of the Elixir Stream Week, and hope to see you again soon, maybe at the Elixir Conf in Krakow next year.